Hello class, this is Math 1430. Today we're going to cover section 6.1, antiderivatives. So it's the opposite of what we've been doing with derivatives. And another word for antiderivatives is integration or integrals. And the symbols in blue are what you always see to denote an antiderivative. The elongated S is called an integral sign of some function f of x. And then because the function is in terms of x, we always write dx. So you always see these symbols together for integral problems. The integral sign of some function of x, dx.
They're handcuffed together.
They're handcuffed together. And once you do the integral, then you drop these symbols because you don't want to keep on doing integrals forever. Okay, so my brother's going to tape.
Hello, class, and here is Brother Dave.
Okay, so this is the opposite process of antidifferentiation. There are two main processes of calculus, the derivative and the integral, otherwise known as differentiation and antidifferentiation. And again, another name for antidifferentiation is integration. Big words, but really, it's not that big of a deal. So, let me get my pointer here. And here we go. So section 6.1, antiderivatives, otherwise known as integration. We use the symbols, the elongated S, f of x, dx. So derivatives and antiderivatives are opposite processes. Here's an example. We know this already. d dx means you take the derivative. So what's the derivative of x squared? Well, by the power rule, it's 2x. And now, suppose you know the derivative and you want to get back to the original function. What you do is you take the antiderivative of your answer 2x dx. So this means the antiderivative, because this is the derivative. If you do the antiderivative, you should get back to x squared. So the antiderivative of 2x dx, otherwise known as the integral of 2x dx, and that's going to equal, by the power rule of integration, which is a little bit different, you're going to get x squared, and then you always have plus some constant c. So this is our answer. It's like a family of curves. And the reason why this is the answer is because if this is called the antiderivative here. Notice I drop these two symbols, the integral and the dx. Once I do my integral, this is my antiderivative. As a check, if I take the derivative of this antiderivative, I should get back to the 2x.
The original function.
So what is the derivative of x squared? 2x. Plus, what's the derivative of any constant, of any number? 0. So this derivative of this antiderivative really is 2x. So let me just say one more thing here. We started off with x squared. The derivative of x squared is 2x. So from this derivative, how do I get back to the x squared? Notice I double underline them. What you do is you take the antiderivative of your derivative, 2x, and then you get back to x squared plus c. So the integral undoes the derivative. Just like addition undoes subtraction, or multiplication and division. Those are opposites. So see the lecture notes which are on Learn for the rules of these integrals. See the lecture notes. Okay, so let's just do one example here. Before I do this example, I want to go to the bells and whistles. Extra. Hey, this is extra. So to show you what derivatives, how they're the inverse or opposite of integrals, I have this little sentence here. So we know this already. The derivative of a distance or position, same thing, function. We know the derivative of a distance function represents the instantaneous velocity. So by the inverse or opposite relationship of derivatives and antiderivatives, we know that the antiderivative or integral of the velocity function represents the, what do you think? What function am I going to say here? And the answer is the distance or position function. So let me just say that again. If the derivative of distance function is the velocity function, then the antiderivative of the velocity will return you back to the distance. So the question mark here is distance. That's the answer. Distance or position. Same thing. Okay, so let's conclude with this final example. So we're told that the profit function for the given margin, we want to find the profit function for the given marginal profit function and the initial condition. So here is our, remember, marginal profit means the derivative of profit. So they give us the derivative of the profit function as this. The derivative of profit with respect to x is this. And this is the initial condition here. When you input 15 into the profit function, you get 22,725.
So let me just interject here. The integral of the derivative function will give you the original function, or in this case, the profit function.
Yes. So here's our solution. To find the profit function, integrate the marginal profit function, because marginal means the derivative. So if you integrate the derivative of the profit function, you'll get back to the profit function. So P for profit is equal to the integral of that marginal profit function. Because this means antiderivative or integral. Isn't the antiderivative of the derivative going to be the original function P for profit? So how do we do this integral? Again, see the lecture notes. But what you do is you integrate term by term. And by the power rule of integrals, you increase the power by 1. So this is like x to the first here. So you increase the power by 1, and then you divide by that number. So that's where the negative 18x squared over 2 comes from. That's the power rule of integration. And then the integral of a constant is going to be that constant times x. And then you always need this plus c, because this is an indefinite integral, as it's called. For all indefinite integrals, you always need a plus c. In a few sections from now, we're going to talk about definite integrals, where you have numbers here, numbers for these endpoints.
And then you don't need the c for those.
Okay, so, and as a check, by the way, you can always check your antiderivative answer by taking the derivative of this antiderivative, and you should get back to here again. And I know negative 18x squared over 2 simplifies to this, negative 9x squared over 2, because 18 divided by 2 is 9. Okay, so if I take the derivative of this simplified answer, I would have a negative 18x plus 1650 plus 0. Derivative of any constant is 0. And that's exactly what we had in the beginning, negative 18x plus 1650. So we know we did our integration correctly, because if you check, which you don't have to do, but if you check, then you should get back to the original, which we did. Okay, and then finally, what is the point of having the initial condition? So you can solve for c. So to solve for c, use the initial condition that when x is 15, the profit is $22,725. So for profit, we're going to write 22,725. We know that's the profit when x is 15. So the profit is equal to this right here. So wherever you see x's, you're going to write 15s. So therefore, we have 22,725 equals negative 9 times 15 squared plus 1650 times 15 plus c. c is our only unknown, so that means we can solve for it. So when you use a calculator, you're going to get, I skipped a couple steps, but this is what you get when you use a calculator. This plus this is 22,725 plus the c. So when I subtract 22,725 from each side, I get 0 is equal to c, or c is equal to 0. So c can be anything, you know. In this case, it turns out c is 0. So for this c here in my profit function, replace it with 0, which means you can just ignore it. So there's my final answer for the profit. Negative 9x squared plus 1650x. That's 1,650x. Okay, so I think that about covers it. And I hope all of you are doing well and staying strong and keep on fighting the good fight. We are 2/3 done roughly of the semester, and you can do it. Good night, everyone.